Sweet, we're good.
We're live. Okay, Clark Christensen, Wesley Butler here. Group 8 problems. So question 1. It gave us a normal chromosome and an inversion chromosome, and it wanted the allele and centromere composition for the 4 products if there was a crossover between the S and T. So we drew it out and lined them up so that we could cross it over. And these are the answers that we got. So for product 1, we got, these are all caps. So LMN, centromere, OPQRS, Product 2, we got all caps LMN, centromere, OPQRS. And then in lowercase, we got TUV, centromere, NML. And then product 3, lowercase XWRS, and then in all caps TUVWX. And then product 4 is all lowercase LMN, centromere, OPQRS, TUVWX. And that is all for question 1.
For question number 2, it was pretty much just a vocab question. So A, we got meiosis 2 and mitosis. For B, we got paracentric inversion. C, the first blank was Turner syndrome. The second one was familial Down syndrome. And D, we got liver cells. E is Cri-du-chat for the first blank and type A hemophilia for the second blank. F is duplication, and G is alternate segregation. That's
Then question 3. So for A, it asks for how many total chromosomes would be in people with these different conditions. So on A, the first one that it says is with Turner syndrome. We said 45 chromosomes. On Jacob syndrome, we said 47. On the Cri-du-chat, we said 46. On familial Down syndrome, we said 46. And on type A hemophilia, we said 46. On B, it wanted to know which of the terms that were listed was not associated with the Charcot-Marie tooth disease type 1A. And we said that was the ones that were not associated were the diploid and duplication terms. Question C wanted to know which terms were associated with the Klinefelter syndrome. So we said that aneuploid, trisomy, and non-disjunction were all associated with that syndrome. And then D asked about what terms were associated with type A hemophilia, and not one of those was. And that's all for 3.
nice. For number 4, it was really just doing some synapse mapping or synapse diagramming. And so mine's not as pretty as Clark's, but there's my number 4. For A, you just had to take each of the allele arrangements they had there, and there's 2 per chromosome because there's going to be 4 chromosomes. And so the ones that have not changed at all or are kitty corner to each other, and then the ones that got changed are also kitty corner to each other. So it makes up a nice, cross area. For letter B, identify the allele composition of the gametes produced by alternate segregation. So that one, in cell 1, we had D, E, F, G, centromere, I, J, K, L, and then M, N, O, P, centromere, Q, R, S, T, and then cell 2 is just the inverse of that as far as the 4-way cross goes in letter A. For number C, do the same thing but with adjacent segregation. And so pretty much it just took the the bottom half and the top half, however you wrote it, and then the bottom two, those each went in a cell, and then the top two, those each went in a cell. For letter D, you take the two on the right, and those each go in a cell, and then the two on the left, those each go in a cell. And so that's how we diagrammed synapses and identified segregations.
And then question 5 was talking about cat chromosomes. And it wanted to know how many total chromosomes there were in a cat with the different things going on. So it asked if there was a triploid cat, how many chromosomes would it have? Well, the cat normally has 38, so if it's triploid, it's going to have 57. On B, it says a cat that's monosomic for chromosome 12. We said that that cat's going to have 37 chromosomes total. On C, a cat that has suffered a terminal deletion on chromosome 7. We said that he's going to have 38. Is that right?
Yeah.
A cat that has suffered, D, a cat that has suffered a Robertsonian translocation between chromosome 17 and 18. We said that he's going to have 37. And E, a cat that has suffered a reciprocal translocation between chromosomes 6 and 9 will have 38 chromosomes still.
Nice.
That is all.